powerful sense, and that is why we believe in Team Afi, which was named after the Greek word for touch. Imagine being able to control things with a swipe of a finger. Afi would be a smart controller that can be used to control your cell phone and other applications. What makes Afi different is that it is a controller made out of patterned textiles, which means you can wear it as a garment and utilize it in your everyday activities without changing your style. Next, we will show the hardware that Afi is utilizing.
One of the main objectives of Project Afi is to create a conductive matrix. This matrix will be able to recognize different touches. This experimental matrix has variable resistance depending on the point where it's being touched. The matrix is controlled to a Flora microcontroller while the capacitive touch program is running. On the screen, the resistance values are being shown. As I swap my finger through the matrix, the resistance values change as well.
The second most important part of this project is the ability to send data over an application to control a device. That is where the Bluetooth plays its role. For Afi, we are using Adafruit's Bluetooth module.
Oh, hello there! Conductive thread can carry current the same way that wires can, which means it can be used to create a circuit. This will allow us to sew different patterns to form a unified circuit. One of the challenges we have faced with Team Afi was learning how to pick the correct thread. We learned that conductive thread can fit into two categories: metal-coated thread, such as silver, nickel, or copper elements, and steel thread. Metal-coated thread is comprised of individual filaments, each coated with micron-thick layer of natural silver. The filaments are wounded together to form a finished thread.
Stainless steel has no core thread. It's made up entirely of stainless steel. Throughout our studies, we learned that this type of thread contains a lower resistance than the coated threads. Therefore, it's very important that we pick the proper thread for our purposes. We calculate the total resistance the pattern can handle using Ohm's law, then divide the resistance by the total length of the power supply and the components. Then we look for the thinnest thread with the lowest resistance possible. While we were doing this, we learned a safe and unintimidating way to use embedded electronics in our wearables. Throughout the video, we've shown you about 20% of the hardware we're going to be using with Afi going forward. We showed you the conductive matrix as well as the Bluetooth module that we're going to use to have interconnectivity. Over the following months, we're going to put these components together as well as add other features and bring Afi to life.